Hello and welcome to MacQT. This is the first lecture of control system engineering, and the topics that we are going to cover in this lecture are pretty basic and probably the most important for understanding, modeling or designing any control system. First of all, we are going to talk a little bit about what is control system, basic definitions and a little bit explanation. Moving on to the main reasons why do we need a control system, and then we will talk about the major components that comprise the whole control system. Finally, we will discuss the two main configuration of any control system, that is open loop control system and closed loop control system. Before going to the control system, let's see what is a system. So a system is a set of things working together as part of a mechanism or an interconnecting network towards a common goal. So basically it is a set of many things working together to make a mechanism possible. In other words, it's an interconnecting network towards a common goal or output. Then moving to the control system. So control system is a system designed and set to obtain a desired output with desired performance level having specified input. So basically it is a set of things. It is a system, so it is a set of things that is specifically designed and set to obtain a desired output with providing a specified input. So we will be providing a specified input that's obviously controlled by the operator, and the system would provide us with the desired output. So the desired output is controlled by the system designed, and obviously the output would be having a certain performance level. The performance level is actually the response of the system. How quick is the response, how well the system responds, that is the performance level of that designed system. So this is the basic definition of any control system. Let's go to the reasons why do we need a control system. So there are four primary reasons for using any control system. The first one is the power amplification. Low input yielding high required power. For example, you can rotate a huge and heavy antenna just by rotating a small potentiometer. So the input provided was the rotation of a potentiometer to a desired position, and the output gained was a rotation of a very huge and heavy antenna to the desired position. Second reason is the remote control, controlling a system through a remote. It is required where being there with the system is not an option. Like for example, controlling a robotic arm in a radioactive location is not possible for a living being. So you can control the system just by a remote control. The third main reason is the convenience of the input form, providing an input that is easily available. Like for example, you can change the position of a thermostat, and as a result you will be getting the heat or cooling in the output. So the input was quite convenient just by changing the position of the thermostat. The final reason for using control system is compensation for the disturbances, maintains the output during the disturbance. So if we go back to our previous example of the rotation of the antenna, so if you set a desired position for that antenna, and let's say there is a wind blowing with a high rate, and that wind would try to change the position of the antenna from the desired position. So the control system would try to maintain its position at the desired position. So that's what is the compensation for the disturbance in the control system. Let's have a look at the components of a control system. The first component is the input. This is also called the reference value, and the desired output is totally dependent on the input provided or the reference value. Second part is the transducer. So converts the signal in the form to be used by the controller. The purpose of the transducer is to convert the input value in a form so that it can be understood and used by the controller. The third part is the summing junction or summation point. Finds out the difference between the present output and the desired output, called the error. So the purpose of summing junction or summation point is pretty much clear. That it checks whether our actual output is equal to the desired output, or the actual output is less than the desired output, or it is more than the desired output. So that's the function of our summation point. Then comes the controller. So controller controls the plant or process based on the error received. So whatever the summation point gets from the output, it is fed to the controller, and controller decides and controls the plant or the process. The plant or process is the actual device or physical body that is to be controlled. For example, if you want to control the temperature of the room, so the room is actual plant of the system. Then output or control variable, the final actual resulted application. Like in the same example of controlling the temperature of the room, the temperature would be our control variable or the output. Feedback control. So it is actually a sensor that senses the actual output and converts it to negative. So the feedback is monitoring the output continuously. Like in the same example of the room temperature, the feedback would be monitoring the temperature of the room every time and sending it back as a negative to the summation point to let it know what is the temperature of the room presently and whether it needs to be increased or decreased. So that's the function of the feedback control. Let's have a look at the two major configuration of a control system. Starting with the open loop system, a control system in which an input alters the output, but the output has no feedback loop and there is no effect on the input. There is no compensation for disturbance. So a control system in which an input alters the output, so that means the output is completely dependent on the provided input, but the output has no feedback loop. The output is not monitored or sensed so that to know whether the output is the desired value or it is greater than that or less than that. And there is no effect on the input. So based on the actual output, there is no effect on the input because we are not monitoring the output, and we are not changing the input based on that output. There is no compensation for the disturbance. So if there is any disturbance in the system, we will not be able to compensate for that because the disturbance will also be changing the output along with the provided input. So we will get to know it in the block diagram as well. So this is general block diagram starting with the input signal or reference value, and then it is fed to the transducer. The transducers try to change the input signal in the form so that it can be understood by the controller, while the controller tries to control the overall process or plant, and then plant is providing us with the output or control variable. As we see, there is no feedback loop, so the input will not be changing based on the output received. Now if there is any disturbance within the system, obviously we are not monitoring the output, so the output would be the combination of the input signal fed into the transducer plus the disturbance, because disturbance will also be trying to change the output, and we will not be able to compensate for this disturbance in an open loop system. Examples of washing machine, light switches, gas oven, etc. Now let's see the closed loop system. So in closed loop, a system that senses actual output continuously through a sensor. So the difference between open and closed loop is that in this type of closed loop system, the output is sensed continuously by a controlled transducer and compare it with the input to help the controller get the desired output. Now the actual output is continuously sensed and it is compared with the desired output to let the controller know whether the actual output is more than the desired output, less than the desired output, or it is equal to the desired output, and compensate for the disturbance as well. So if there is any disturbance within the system, the controller would get the actual output and it will try to maintain its position. We will get to know it better when we see the block diagram of it. So this is general block diagram starting with the input or reference value, and which is fed to the transducer, to try to change it to a form so that it can be understood by the controller. Then there comes a summing junction, we will get back to it. And then the controller. Now controller is trying to control the plant, which is providing us with the output or control variable. Now the only difference between the open and closed loop is that we have a feedback here, which is trying to sense the output continuously and send it back to the summing junction as negative. Now the signal coming from the transducer would be positive, while the signal coming from the feedback would be negative, and the difference would be called as error, and the signal leaving the summing junction and going towards the controller is known as the error signal. Now this error would be either positive or negative. For example, if you are controlling the temperature of the room, so if the actual output or actual temperature is more than the desired temperature, then our error would be negative. If the actual output is less than the desired output, then our error would be positive. And based on the sign as well as the value of the error, the controller would control the plant. We will understand it in the example coming up. The examples are automatic electric iron. So in this case, heating elements are controlled by output temperature of the iron. Secondly, air condition. So an air conditioner functions depending on upon the temperature of the room. Now let's look at an example of both the cases. For the open loop, let's say we are using the example of a dryer. So the set time would be our input, like for drying our clothes, and the controller would be the timer, which will be allowing the electrical energy to flow through the elements. Now in this case, if the timer is on, it would be letting the electricity flow through the element. When the timer is off, there will be no electricity flowing to the elements. So in this case, the timer is our controller, while the heating elements are our plants, and the process is moisture content, which is the removal of moisture from the clothes to get it dry, and the output is dry clothes, obviously. Now it is an open loop, so we are not checking continuously whether the clothes are dry after a certain time or not. So we have to come and check ourselves whether the clothes are dry or not, and if they are not, we have to set the time again and make the loop continue. Otherwise, if they are dry, so well and good. While in closed loop, it will be sensing the output continuously. So starting with for the automatic electric iron, starting with the desired temperature. So in electric iron, we set the temperature, that what should be the temperature of the sole plate of the iron. So that will be our desired temperature. It will be fed to the thermostat, which will convert this set temperature into an electrical signal so that it can be understood by the controller. Then controller would be controlling the electricity flow to the heating elements. So in this case, the heating elements is our plant actually, which we are trying to control, and our output is the temperature of the sole plate, obviously. Now this temperature is continuously being monitored and sensed by a sensor, which is obviously another thermostat, which is sensing this temperature continuously and sending it as a feedback to the summing junction. Now again, in the same way, the difference of the feedback as well as the input would be our error, and the signal is known as error signal, which is leaving the summing junction and entering into the controller. Now based on the value and sign of the error, the controller would decide whether to let the electricity flow through the elements or to stop it. Now for example, if the temperature of the sole plate is more than the desired temperature, so our error would be negative, as the negative is more than the positive, so our error would be negative. In that case, the controller would stop the flow of electricity to the heating elements, and the temperature would be obviously reduced to the desired temperature. Another way, if the temperature is less than the desired temperature, so a negative value would be less, while the input, which is the original desired temperature, would be positive, so our error would be positive. Based on that, controller would let the electrical energy flow through the elements, which would increase the temperature to the desired temperature, and that's how it maintains our desired temperature automatically. Now, for the next lecture, we will talk about the analysis and design objectives, which are transient response, steady state response, and stability. And then we will also talk a little bit about the design process. We will be talking about the CAD software and its importance in the modeling and designing of a control system. Thank you so much. Thanks for watching. If you like this video, please like, share, and comment. If you have any problem, please do comment. I'll try to answer them. And please do subscribe to my channel. Wish you best of luck. Thank you. Goodbye.